I've already made the test, but here it is again. 1 second to make better spacing, and it wants there near the connector, but I don't like how it is. This will get very hot, and this being short, it's not good. Let's see. It's good enough. And there it is. I will not let it overheat because I don't want to damage the probes, the connectors there. And it's already smelling dubiously here. It was having some dirt probably on it, and now I took it out. This is my connector here, and this is a transformer. I will explain everything. I put this just to heighten up a little bit, not to be right on the floor. Not that it matters. This is the 240 volts. This project is a winner. This project, unbelievable. It is a winner, and that's it. Absolutely fantastic. Absolutely fantastic. I really love it, and I also am thankful to that guy from YouTube that made the experiment, and I could replicate it here, and it's absolutely working fantastically well. And voila, here it is on my table. I followed. I already mentioned already. I was for a very long time, very long time, from when I was an adolescent. I wanted a spot welder, either to build one or to buy one. And to buy one, I was always disappointed because commercial spot welders are very expensive, for a couple of hundreds of dollars if you are lucky, and even going up over $1,000. The serious spot welders, not toys. And something like this guy is doing here is a couple of hundreds probably dollars in a commercial way. But I followed, and this couple of days I was having problems, very big problems actually, with some pins of some SMDs chips, not chips, LEDs, the pads of the LEDs. It crossed my mind, it should be very interesting to actually spot weld wire to their pads and practically make those SMDs LEDs with legs, pretty much, by spot welding some legs on them, wires. And because this was a very old idea of mine, a very old wish, pretty much, I wish it for a very long time. And I got through numerous websites, I got through numerous explanations how to build ones, but they've always been not that informative, not that complete, not that certain. I was also afraid, I'm still afraid of this monstrosity that I'm having here, but is working, and I was afraid of something getting in flames from the transformer itself. I wasn't sure how actually, maybe I missed something, maybe I didn't do it correctly. That's why I didn't really trust anybody until this guy, I find it on YouTube. Very important detail is that this is absolutely my first spot welder that I ever built. I don't think I will make another one. This is the first in my entire life. I don't think I will make a second one. But also he's having a blog, website, where he is explaining in more detail everything. I will show it in a screen sharing. I will record the screen on my computer. But right now on the table, this is what I'm having here. I followed as exactly as I could his explanations and what he is showing. He is not actually talking at all. He is only showing. I don't know this guy, but I thank him either way, because he, in a sense, he, not that he saved my ass, but he fulfilled a very old wish I had. I really wish it for a very long time to have a spot welder. I realized after looking on a few websites, a few movies about spot welders in general, on the forums as well. I was reading the comments, they were on the forum. Even the question wasn't my question, but the answers were close to what I wanted. And I formulated in my head an idea. How I reached this stage that I trusted this guy to build his project, and I trusted him pretty much. I trusted him, and I was partially sure it will work, but I was partially unsure I will fuck it up and something will blow up or get in flames, or even worse, get electrocuted. Hopefully not. And I was very, very careful all the time. I am shitting my pants when I'm seeing this monstrosity of cable here. It's pretty sick. This is electrics, by the way. This is not electronics. Electronics is dealing with small voltages, very small voltages. Let's say under 20 volts. Under 20 volts is the field of electronics. This is with high voltages and super high voltages, and this is the field of electrics. It's a very distinctive. There are two distinctive fields, and I know it from my adolescence actually. Even if I'm not an electrician or electronist myself, I'm an artist, but I happen to understand these two differences, and they are pretty important. When you get electrocuted in the field of electrics, either you don't get up after the electrocution, or you have some mutilated fingers, or even the palm itself, you don't have it anymore. That's what happens with high voltages in general, with very high voltages, with kilovolts, or in this case, actually, this is running on very high amperage here, very high amperage. I'm not sure exactly how many amperage is having. Probably 100 amperes, probably. I'm not sure. I have to calculate. I'm really not sure. And I also don't know how to actually to measure it. But the idea that getting back to the original thought that I wanted to explain to you how I reached this conclusion to actually trust this guy, this project, his project, and to trust to copy it and that it will work, and with kind of very good price margins. So the idea that I reached this stage was like this. Pretty much by seeing so many forums, so many answers on the forums, websites, also YouTube movies and etc. I realized one thing. Theoretically, and I'm accentuating theoretic, not practic. So theoretic, if you hook up two wires from the 220 volts, 240 volts from there, from the mains, and you put two pieces of metal, and you make a short with those wires from the 220 volts, theoretically, again, I am specifying very clearly right now. Theoretically, you can weld directly with 240 volts at 40 amps or 30 amps is the line main amperage, something like that. You can weld two pieces of sheet metal, pretty much. But why I'm saying it's theoretical? Because in practice, practically, you will make a short, and making the short will trigger the fuse that is on the panel over your entrance door, and you have to go there and click if it's automatic, and you have to they put in function this line of mains pretty much, because you made a short pretty much, and the fuse got off because of it. That's the practical issue. So you cannot use actually, if that fuse wasn't blowing up, you could stay and fuse directly with those 240 volts. You could stay and let it weld those two pieces, or get hot and red until they get welded, and you take out. But the problem is that fuse that is coming off. That's the practical thing. So the human brains thought of three main ways of storing the electricity that you get from the mains, and not to make the short. That's the problem. The short is the problem. So you have to not make a short, a direct connection to the mains, and you have to store that energy in something. So you have three ways of storing: capacitors, transformer, or a battery. Pretty much these three modalities. And after understanding this little detail, which is very, very important, and I formulated it myself. I didn't read it anywhere, but I've seen hints or ways on the internet, how many ways of making a spot welder there are. And pretty much everything lead me to the conclusion that they are these three modalities of storing the energy. The trick is not about voltage, but is about amperage. The higher amperage that is stored, the better, or you are getting more closer to a spot welder functionality, to actually do the job, not be a toy. And that is only making sparks. So pretty much those capacitors, if you want to make it with capacitors, you have to store a lot of current, not the voltage. The voltage can be very low, like 2 volts or 5 volts, whatever the voltage, but the current must be very, very high, in order of 100 amperes, probably 50 amperes, but I'm not very, very sure. I know there is a lot of amperage, 80 to 100, 120 maybe, somewhere like that. So those capacitors must keep a ton of energy in them. Also the transformer, and this is the second version with the transformer, and also with the battery. A battery, or car battery, is there are many amperages, quite a few amperages now for car batteries. Before 10 years ago, maybe 15 years ago, it was only one type of battery on the cars, and it was having like 40 amps. Probably, I don't really remember exactly, because my parents don't have a car, but I know from my friends, their parents, they had cars, and I was assisting them, their parents, fiddling and repairing and changing batteries, and I was getting acquainted with with the components that the car needs. And I remember 12 volts for a battery car always is 12 volts at 40 amps, but now I've seen with 55 amps, even 60 if I remember. And lead batteries, those big and heavy lead batteries. And also for motorcycle, they are like 20 amps. I don't think you can do spot welding with 20 amps. I'm not sure, but from 50 amps up, you are probably good to go for a spot welder. And if I'm not mistaken, but if I'm mistaken, I didn't research exactly to the exact limit. I didn't do that. I'm not sure on this transformer how many amps is having, but I'm following someone else's design, and it worked absolutely brilliantly. I love it. And that's the idea with storing a lot of amperage outside of the mains, not making that short that will trigger the fuse. The resettable fuse, because that is a resettable fuse. Back in the old days, like in the 80s and 90s, especially here in Romania, or 90s, 2000s, even from 2000 up until 2000, they were single shot fuse. If the fuse was burnt, it was a couple of strands of. Let me see if I can find. This is very sick. No, a couple of strands, very thin strands, 1 or 2 strands. I don't have it right now in my hand to actually show you how thin everything. Yeah, a couple like this. You put one wire like this, one single wire like this, and you make sure it's making contact metal to metal, not isolation. On two ends, metallic ends as well. The body was made from ceramic, highly isolation, heavy isolation material like ceramic. It was made with white ceramic, and it was having a special shape, like a bottle, like a little bottle, like that, with two metallic cups. And between those metallic cups, inside the bottle, it was a tunnel or a hole, and inside that hole you put this wire, and end to end bended outside, and you put the metallic cups on the connections of that wire that was inside. You made the connection, and actually you were building a fuse pretty much, and you inserted that entire component, that big fuse was inserted into the contour. We said it here. I don't know how it's called in English. The big panel, the big electrical panel, and you insert it there, and until the next over current or over amperage or short happened on that specific line that fuse was responsible for, because you have multiple lines, like 3 or 4, depends how big is the house, and that's pretty much the fuses and the currents and the big, very big scary currents here. You don't have to play with this stuff. I don't have to play with this stuff, but it was a very old dream, and I was very courageous on building it. I'm not recommending it to anybody to build it unless he's courageous and crazy like I am, and he really needs it. You don't have to build it if you don't need it. But pretty much this is the how I'm having it. I will explain everything on my screen screen capture video, and I will explain how I build everything. I hope I will take some pictures as well from what is here. I didn't film anything while I was building this thing because it was a pain, very hard to make it. It was a bit hard to make it. It was hard to find all these components because I didn't have them. I went, let me tell you the story of these components that I'm having here. This is a transformer from a microwave oven, and I find it, I bought it from a repair shop here in my town, and I was very, very lucky to find that shop and that guy to actually have these transformers. He was having like 3 or 4, not many. He was repairing something else, not microwaves, but he had this on a shelf there, just because. And I had to took out. I only leave the primary of the. This is a paint. Is not a. Is a bit. So I leave only the primary of this transformer intact, and I was very careful, very careful not to scratch it in any ways. And I took out the secondary that was here instead of this black wires, and also another secondary. Secondary. It was having 2 secondaries, and the second secondary was. Yeah, this is it. This is the second secondary that I managed to pull out the entire wire. It was like 4 wires wrapped, and then the wires were getting out, and that's it. I measured it, and it gave me 3 volts, 3.6 I remember volts. Most probably this secondary was for electronic boards from the microwave device, and this first secondary, the real secondary, was feeding the element that is producing the microwaves. I'm not into microwaves, not at all. Well, all that I'm interested in is to make this stuff work. Then this is a welding cable. The dimensions are very important. I used 1.5 meter long. Actually, I bought 2 meters of, and I have there the rest that is from this wire, and I bought it from Bazaar. I went to Bazaar and I find it there. In my country, if you had to buy 1 meter, it was 35 lei. My currency is in Romanian lei, and it's 35 lei per meter, per 1 meter. And I find it in Bazaar, where you find scrapped stuff. And this is absolutely not new. This is used from a welding cable, and I find it with 20 Romanian lei per meter. So I buy 2 meters with 40 lei. Almost like 1 meter that I find it in the store. That cable from the store, I find it wasn't for welding, it was for cars, and I'm not sure if it was thick enough. It was very thick actually, but I believe this is better. This is way better. And is not staying. It's having fibers inside. You see, these are fibers, strands. And I actually, this is rated for 150 amps. It's the biggest I could find. I actually find these smaller ones originally. I couldn't find. I went everywhere and I couldn't find this kind of connectors. I barely could find these guys, which are tiny. And even these ones that I have here, the largest that I could find, didn't actually overlap themselves, because that's very thick cable there. This is a kind of intermediary now, but I was really thinking this will do the job when I bought it. And then I said, give me a bit bigger than this. And I bought this two and this two. And in the end, the bigger ones were the proper size, because I didn't took a sample of the cable with me. It's quite heavy. And this was a problem to find this. And the people were trying to sell me very expensive plugs here. Not plugs, how they are called, connectors, lugs, they are called lugs. It's a new word for me actually from English. I don't use this word very much, and I never use it actually. And these lugs were extremely expensive and bulky, of course very powerful to resist to a lot of amperage, probably in order of a couple of hundreds amperage more than this one. But I don't need that kind of amperage resistance on those ends, and it was Not really, very very expensive, like 20 Romanian lei per one connector, and no, it was a steal. These are 2 lei, 2.5 lei per one, so 5 lei, 2 of them, and also for those as well. And this was 1 leu per each, so 2 lei for both of them. And so yeah, it's not 20, it's a big difference. And this I built everything that you see here. I built it in 3 days. It took me 3 days. The diameter of this cable is very important for someone to know. It's exactly 1 centimeter diameter. If you put a ruler, if you put a ruler here, it is from the very margin from here to that is the 1 centimeter. But the cable is a bit, and you cannot see, it's black on black. The cable is a little bit larger, so it's 1.4 millimeters in total because of this black isolation. So it's 2 millimeter isolation, and side by side, and interior is 10 millimeters thickness of the wire. And pretty much this is it about this cable. It fit perfectly. This distance here was a little bit, I was also lucky. I was very lucky actually. Let me open the light a little bit, and it's making a lot of contrast, like that probably. And let me measure it. Let's see if I can do it like this. It's 1.5. You cannot see because my finger, and it is 1.5 here. You see, 1.5. So 15 millimeters. 1.5 centimeters or 15 millimeters wide, almost. Probably it's less. Probably it's 14. But this cable is let's see. Actually, I can measure it on top of it. 12 millimeters, 12 or 13. You see, 12 or 13 millimeters. And I was very lucky of this large hole that I'm having here, and also this diameter. I kind of I was searching actually for a number 8 diameter inside this copper wire, inside this. Electrode in a sense. This wire, I was searching for 8 millimeters inside, but in the end it turned out it was 10 millimeters when I reached home, and I tested it immediately. I tested it if it's entering there. I was very sure I will have to cut the isolation from it and to make room, and I was very very lucky to. So be very careful with the wire dimension if you have to build something like this. Also, you will have to learn. It's a learning curve. You have to read a lot of stuff, watch movies, watch forum discussions about this project, read the blogs or papers on the internet, familiarize with the subject, and then came to a conclusion, because it is having its own learning curve. It took me like a couple of days actually to learn to read everything and to formulate myself an idea about what it is and how to do it and what to trust. That's the most important thing, who to trust and what to trust. And I trust this guy, and I said, fuck it, I will work on his model, on his principle, on his project, and it's fine. Right now it's absolutely awesome. All right. Also I bought these screws that are from inox. At least in my language they are called inox. In English it's called stainless steel, and pretty much is steel that is not oxidating or getting rust on it. Is usually used in medical or sanitary, in general sanitary places where you don't want accumulation of rust or oxides of any kind, like and I'm not very sure the original project, the guy that he built this project, he is using copper bolts, screws, and I didn't find, I've only find this inoxidable screws. I will have to test them. I'm not very sure if they will work. I will have to find harder some screws that are from copper. There are a couple of special elements to this project, and I am very aware of it, but it beats out the price that you will have to pay on a commercial one. The commercial one will be 10 times higher price than when you will build it for yourself, even by making mistakes and not getting the proper components in one shot, like I did here. But I will have to test them, and if they will work, hallelujah, I'm awesome. I was very lucky if they will work, but if they will not work, this inox screws, and I will have to actually put the copper ones made from copper, also the screw and the nut here, so both of them, or probably something that doesn't matter, the nut, but the screw itself must be from copper, and that's very important. And we will see with this part here. But so far I was very lucky. Also the hole here is pretty large, and you see it's absolutely fine for this, guys. These are number 8. The diameter is 8 millimeters here for the screw, and that's it about the screws. A small update, well, a very small detail that it matters. I made a list here. I printed on my printer, and I've also made some drawings here with my crayon. Electrical terminal, it means in English, cable. That is the cable, and this was the connector that I originally was hunting for, but it was extremely expensive. And another connector like this, which I find, these guys here. Why these guys? Because behind here, on the, you see, I'm having these connectors here. These are a little bit larger, but if I will press them a little bit more, or deform them a little bit with a plier, they will press fit. They are already press fit good enough, but if I will have to modify them a little bit, they will absolutely perfectly fit there, and that's important also. Right now, I've only sold these two test wires that will not remain here definitely definitively. They are just test wires, and I will put proper insulation, proper everything. And this, like I said, this is a good thing to have. Let me push this away a little bit like that. So this is a good, very good detail to have a list with everything to be extremely clear what you want to buy. Here are the prices that I already paid on everything, on microwave, oven, transformer. I written them in English, but partially in my language as well, somewhere there. I don't know where. But this is the microwave oven, the transformer itself. It cost me 50 lei. This 1 meter, actually 2 meter cable, 40 lei. This cable here, 4 lei, copper logs. But I put here this 4 lei for this. These guys that didn't actually fit. It was I find them in the same day. In the bazaar, everything I find a lot of stuff I find in the bazaar. But after today, after other 2 days, I find these guys that were bigger. And let me throw this away because I don't know. And these guys that actually fitted perfectly, and I'm very, very proud of them. And they are adding here plus 10, in total 14 here. So 14, like that. These screws cost me 2 and something, probably 5 lei, 4 and something lei. Not exactly 4 lei, but let's say it was 4 lei for the screws. Only these two screws, they were quite expensive because they are inox. They are usually a normal screw from mild steel is way cheaper. Is like 0.1 or 0.2 lei. But this was 2 lei per one screw because they are special screws. That's why. And the rest, and they are not even the copper. It should be copper bolts, bolt screws. And also a fan for that doesn't matter. The fan I can add a special transformer, a separate transformer with a normal fan. 5 volts or 12 volts or whatever. This is not a problem. An on-off switch that is switching to 40 volts, pretty much like this one, that is switching the mains coming into the transformer. It worked with this guy as well, but I will put probably a better one. I will see what I will find. But this is the list that I wanted to show you, plus some drawings there to show the people what you are searching for, and they helped me. A lot of people recognize them and told me very quickly, yeah, I have it, or no, I don't have it. So pretty much this is it. All right, to make the cost, the price. So I will calculate everything in Romanian leu or RON. I'm not sure what RON stands for. RO definitely stands for Romanian, but N stands for new probably. So like new currency. Romanian new it means. It should be ROL, ROL. But it's like Romanian leu, but they didn't like it. They choose it N instead of L, and you cannot find it other way on the internet, unfortunately. It's very strange way. It's not it's not easy for other people to get this currency to convert it, because here in this country there are a lot of shit. Okay, so let's see, 50 lei for the transformer plus 40 for the cable plus 14 plus 4 the bolts that are not yet copper equal 108 lei. Kind of expensive, but it's quite good. 108 RON. Yeah, it is already converting it in euro, but I don't. I'm not with euro. I'm with the dollar, American dollar. RON to USD. Let's see, 23.26 USD. What? RON equal 23.26 USD equal to euro 22 euro equal with pounds in England 19.30 I'm not sure lira. So that's is the same price, which is I'm most used with USD. So you can find at this price you can find 23 or something spot welders, but they will not even be close the power of them as this one that I've built from and the materials that I'm using here. The commercial one will have way less power cords, the wire, the power wire, the lugs on it, and it will not even get close to the good stuff that you can make by yourself. That's my point. All right. This is the list that I made, that I printed actually. This part here I printed, and then I've added here. I reshaped this list after that, after I printed it. But this was the plan from the beginning, and I follow it. And how did I manage to get this information, what I really need? Well, I watched this guy movie here, how to make a spot welding machine. But when you have it like this, a very small window, you see this guy is called Mystery Mac, but in reality it's called Mystery Make Tool, and you have to be careful when the shortcuts are, yeah, if you do it like that. And after I watched his movie, I will not, of course, play it with you. You have to get it. But I actually have some pictures from his movie. Here is I've measured this coil. This only 4 wires or coils, only 4 coils from this red wire, and it gives me 3.6 volts. But I don't really need it. Really, I don't need it. I was thinking to let them to use them, but no, I don't think I need it. So I took them out as well. This isolation that you see here, this shape. Let me actually draw it on top. So you see it here, like this, here, and here. and like this, you see it, and probably is over here as well, the thickness of it, and then the thickness of it is going like this. And this shape, this is mica, is not a cardboard. I was very sure this is a cardboard, but it's not. It's mica, a very good electrical isolator, and I was very surprised, very interesting. And they used some sort of glue that was extremely dry, and it was cracking very kind of easily, which helped me to get rid of this red wire at least. But from the isolation that it was before, the secondary here, it was also glued with that very cracking. This yellow stuff that you see exactly here, you see, this yellow stuff is a glue they used all over this transformer. Here as well, you can see it also here, but that doesn't matter. I'm showing you all these details about this project because I didn't find all these details anywhere, and I made my own decisions, and they were right. This is from the movie itself. He is specifying that he used this copper bolt that is 8mm diameter, but not in the video. In the paper that the page with details, with more details. And after I understood that the screw is all 8mm, then I took this measurement from here. I made this red marking here in Photoshop, and I put it here. And this is looking like very close to 8mm. In reality, it was 10mm. At least for me, it was 10. Probably for him, it was 8mm. But who knows? Maybe the isolation here, a little bit of isolation. I don't know. Maybe it was 9mm for him. But it was very close. And you can see how intuitive I made it to actually figure out how thick this cable was, because he didn't mention it at all, the thickness of the cable, because he thought this is a standard cable that is everywhere, but it's not everywhere in this world the same. And here are the lugs that he is using, very expensive. They are from copper, actually. They are from copper, and they are like silvery, but it's actually copper, and they are extremely expensive, at least in my country. And I optioned for the other models. This is his transformer, and my transformer is looking absolutely exactly like his. So that's it. Secondary windings, 2 turns. So he's coming here, 1 turn here. When he's coming out, is 1 turn, and when he's coming in, another turn, and he's coming out completely on another wire. And that's it. And the primary is maintained, is protected primary, and all the secondary he took it out. And this is his test. Actually, his nail actually melted until it broke. I didn't let my nail melt until it broke because I wanted to protect the lugs that I have here, and not to overheat them. And but it did light up this nail. In my case, this is the test. You test it, and if it's doing this, that's it. Project finished. Project is working. And here is the cable that he was using. Here is it says here 50 square. SQ it means square. My friend from England, he helped me with that. This shortcut SQ, I didn't know what it meant, but he illuminated me. He said that this is squared. So square, it means to the power of 2mm. So 50mm. Let me actually show you. Yep, this is it. So you see, this is it. This is what that cable actually says here, 50 square millimeter. They couldn't put a fucking 2 there. So this is the unbelievable. So this is the 50 square. Let me actually do it like this. It means 8mm in diameter, and the diameter you can take it out with a ruler, and you don't have to shit yourself with 50mm square bullshit. That's very, I don't like it, but yeah. But this is how you figure out how 50mm squared to diameter if you want to, using Google. And this is another shot. It is also saying here welding. Let me see. Yeah, welding cable. His cable was for welding as well, but mine is better, is thicker than his. And that's it. That's all the pictures that I have from his movie. Let's get back to his movie. Where are you? These are other, also a spot welder that I find, and is actually 20 because it's 15 here, but plus shipping 5 and is 21. 5. And this I didn't like it. I've seen a review of it, and is working up to 1mm thickness of the sheet metal that you want to melt to spot weld. But if it's 1.3mm thickness of the sheet that you want to spot weld, it will not manage. He cannot spot weld it at all. And I've seen some comments. Yeah, if you change the lugs here, I believe it was, or something. I think it was bullshit. But this is quite specific. This board, I'm not saying it's bad, but I'm saying that this kind of boards that you can find them anywhere, everywhere, is 12 volts from a battery. You have to buy the battery, a 12 volts battery from a car, or a car battery, and it will cost you exactly the price that cost me to build the transformer spot welder that I already did here, and it's the same price category. And also the capacitors, if you want to do it with capacitors, also they are also very expensive, and you will not get more cheap. You have to invest a little bit of money, and if you are lucky to find already used stuff, to pay it for a little bit less than they are when you buy them for new, you are lucky. And you have to work, to move a lot and to research a little bit. You will not make it in one day. I make it in 3 days, also having luck. I was a bit lucky, but I also did a lot of bullshit, a lot of shit. I wasn't lucky all the time. Okay, so this is his movie where he is explaining, he is showing how he's cutting the secondary there, the cable here. It was too thick, and he is getting rid of that black copper isolation, and it remains with that white isolation, which is very thin isolation in my opinion. It should have the proper isolation all along, but doesn't matter really. It matters that he managed to insert it into that holes. He is plugging the lugs here, and also putting some not very important isolation there, and he is making the test. Let's see his test, which is absolutely phenomenal. It broke, and I didn't did it in mine, but it did got very hot. And that's it. And the rest of the movie is how he's actually building the finished machine. Here is another test with he is spot welding 2 nails, one on top of the other. Very good acrobatics he did there. They are very hot, that's why he's keeping them with the pliers, not with the bare hands. And also a stress test right now. Absolutely phenomenal. He and he's looking very nice as well. I give him a 10 from 10. He did it absolutely awesome. And here is how I find about his page. It says here, when you press this little button here, show more, you see? And when you show more, when you press the button, you can read. Not everyone is showing stuff. I'm not showing stuff because I don't have to. But some people are showing their stuff, some additional stuff that they have. And in this case, he's having an official website. I was thinking it's a blog, but it's a website actually. And this is the website. But I believe this is the actual the page on his website, and I clicked this one originally, and I couldn't find it, and it's very weird where he put it in what category. After that, after I find this page specifically, then I realized where he put it in his website. But I look it everywhere except one place, and it was in that place. And here is the parts that he used, and he's using all these parts, and I read them, and of course a lot more than what I've noted myself. But I put down what was absolutely important and imperative to have, and yeah, it's working, and I am very grateful to this guy. You see how he took out everything from the secondary. There are 2 secondaries here, and he took them both, and leaving only the primary winding, and the rest. The rest is pretty simple construction, pretty much. It's very simple, and I also have to buy this 2 copper. And my page is fucking up. It's fucking with me for some reason. I don't know why. Yeah, like this. All right. So, and in the end of the page is having the link to the YouTube page. So this is it for this part, and I hope you like it. And yeah, good for him and good for me, because it was hard work until this stage that I built it right now. It was hard work, and I still have to do some experimentation, because I want to do something important with it, and I hope it will work. We will see.